Okay, this is going to be the second video on integrals involving power series. And in the first video, all we did is showed how you might use the integral of a power series to make something easier. If you're given one power series, if you use integration, sometimes you can easily get to a second power series without having to go through the whole formal Taylor polynomial series definition. Now, another use of integration with power series is to allow you to evaluate definite integrals where you don't have a rule to apply. So suppose in this video we wanted to do this. Use a power series to evaluate the integral of e to the negative x squared from 0 to 0.2. Now, before we get started on the power series part of this, it's important to recognize the problem. And I always get a few students that do this. They'll say, well, didn't we already do this using use substitution? And the answer is yes, sort of. We did something similar to it. Now, it's tempting to want to do this, make this be the integral from e to the u, and let u be equal to this. Find the derivative, change it to an e to the u, use substitution, and solve it that way. Now, the reason it worked before is this, is if you had this, if this thing had an x in front of it, sitting right here, then yes, you could use substitution, because the derivative of x squared would get rid of this x, and off you'd go. So that's what the problems looked like before, and that's why you could use substitution to solve this. But if this leading x is not missing, now when you take the derivative of x squared, you're going to get 2x, and you're going to have trouble getting rid of that second x. So in this case, because this x doesn't exist in this problem, then we can't use substitution. So just a quick discussion on that, just because there's always a few students who try to use substitution on these. So be aware of the problems that you can and can't use substitution on. Okay, now the idea on this is this. We want to evaluate this using a power series. And whenever you work with integration and power series, quite frequently you're going to start out with some basic series. Now in this case, the basic series clearly is going to be e to the x. So the first thing I would do is just write that rule down. So go to your book or your tables, or hopefully you have it memorized right now, and write down the basic definition of the power series for e to the x, which looks like this. Now again, frequently in integration problems, before you do the integral, you're going to have to use substitution or maybe multiplication of power series. You're going to have to manipulate it to put it in the form that it looks like in the problem. So in this case, we've got a rule here for e to the x, but the problem is e to the minus x squared. So the first step in this case is going to be use substitution. I think we'll go ahead and just write it right here. We'll call this step 1. So what step 1 is to use substitution . So we use substitution to change it from e to the x to e to the negative x squared. And we've done this previously, so let's just go ahead and do this. And what it's going to look like would be this. If I had e to the x, and I want to change it to e to the minus x squared, and hopefully you're familiar with this from previous work, but all that means is just everywhere you've got an x, substitute a minus x squared. So the original power series would change into this. This would be 1 plus, and in place of the x, I'm going to put a negative x squared. And this is just basic substitution. In place of the x squared, I'll put a negative x squared all over 2 factorial. Then plus x cubed. And actually, in place of the x cubed, I'm going to put a negative x squared cubed divided by 3 factorial. And then I think I'll go ahead and put one more in here. We'll make this be, well, we'll just let it go at that for right now. That'll be okay for the problem we're going to work on. So we'll do it like that. So this is just going to be substitution. Okay, now we'll go ahead and expand that out. So this is going to be e to the negative x squared. And this one would become 1. Then this one would be the negative of x squared. Then on this one, when you square this, this will turn into a positive x to the 4th. So this would be plus x to the 4th divided by 2 factorial. And I think I'm going to go ahead and change 2 factorial into its actual number. So 2 factorial is just 2. Then on this one, you've got a negative cubed, so it's going to be a negative. And multiply the exponents, that'll be x to the 6th divided by, and 3 factorial would be 6, and then plus, and it goes on forever. So what this says, this was step 1, and you've got it in the proper form. So now we'll go to step 2, and step 2 is now go ahead and actually do the integration. So once you've got it in the form that you want, now we'll find the integral. So what we want, and again going back up here to the top, we want to find the integral from 0 to 2. Now first of all, we'll find the indefinite integral, and then we'll evaluate it as a definite integral. So let's move down to here. So the next thing I want is the integral of e to the minus x squared dx, and that's going to be equal to the integral of this power series. So 1 minus x squared plus x to the 4th divided by 2 minus x to the 6th divided by 6 plus, and so on. Goes on forever. Then all that with respect to x. So what that's going to give me, and again, we'll do it just like we did before. When you do an integral, it's going to be term-by-term integration. So just find the antiderivative of each term. So this one will become x. This would become x cubed divided by 2, or pardon me, x cubed divided by 3. So that's going to be minus x cubed divided by 3. Then you've got plus. Then this will become x to the 5th divided by 5. So this would be x to the 5th divided by 5, but it's also going to be 5 times 2. So this would wind up being a 10. And we'll do one more. This will be minus, and this is going to become x to the 7th divided by, then it'll be 7 times 6, which would be 42, and it goes on forever. So what that's going to be, this is going to be the integral, the indefinite integral of this thing right here. Now, what we want, though, is the definite integral, and we want to evaluate it. Again, we'll go back up to the top here. We want to evaluate it between 0 and 2. So we'll go back to here and make this be, in this case, we'll change it from the indefinite, or from indefinite to a definite integral, from 0 to 0.2 of e to the minus x squared dx. And we already know that the integral is this, so if we do a definite integral, and I'm just going to limit this to the first 3 terms. So this would be x minus x cubed divided by 3 plus x to the 5th divided by 10. And just like you've done in the past, we'll evaluate this between 0 and 2. Now, one thing that's changed, and it's kind of an important change, is this, is once I restrict it to 3 terms, as long as it's an infinite number of terms, then it would be equal to this. But once you restrict it to a fixed number of terms, then it changes from being equal to, this is now going to become just an approximation. And it'll be a pretty good approximation, but anytime it's like changing a Taylor series into a Taylor polynomial, you now only get an approximate answer. So to solve this, it's just a matter of, just like you've done in all integration, everywhere you've got an x, substitute a 0.2. So this is going to become 0.2 minus 0.2 cubed divided by 3, then plus 0.2 to the 5th divided by 10. And then on the second one, now minus everything evaluated at 0, but this time all 3 of these would be 0. So this would be 0 minus 0 plus 0. So that whole second term would go to 0. Okay, now what this one's going to be, this would turn out to be 0.2. And if you took this and evaluated it, it will turn out to be 0.02667. Then you've got plus this one evaluated will turn out to be 0, 0, 0, 0, 3, 2. So that's the first three terms. And then finally, if you added all that together, you would get 0.197365. And that's going to be equal to the integral from 0 to 0.2 of e to the minus x squared dx. Now again, it's an approximation, so I'll change that again to an approximation. So this is always just going to be, in each case here, an approximation and approximation. But it's actually a pretty good approximation, because if you go to your calculator and put this on a calculator, the calculator answer would also be 0.197365. So it's actually accurate to 6 decimal places just by using 3 terms. So it's a pretty accurate process. So again, let's go back up and just kind of review the whole process. So the idea is, here's the original series. So start with a basic series. You just have to recognize the form. It's e to some power. So look up the power series, the basic power series for e to the x. Then in the second step, to change it from e to the x into the form in your problem, you may have to use substitution. So replace the x's with minus x squared. So everywhere you've got an x, replace it with a minus x squared. Then expand that, and then find the antiderivative. And when you find the antiderivative, again, term by term integration. So the 1 becomes an x, the x squared becomes this, and so on. So term by term integration. Then to evaluate the definite integral, decide how many terms you want to use, and do it like any other definite integral that you've always done. And you get an approximation for the answer. But again, also be aware of the fact that once you select a fixed number of terms, it turns from an equal into an approximation. So that's just a quick look at using power series to evaluate integrals that you don't have a formal rule for. Because right now, until you got the power series, you don't really have a method in this course to evaluate this. Now, you could get an approximation, I suppose, using maybe the midpoint rule, one of the numerical methods like the midpoint rule or trapezoid rule, something like that. But power series just gives you another option to evaluate these things.